In the next experiment, we demonstrate how managed aquifer recharge works through infiltration in a system where we have already established groundwater flow. The goal is to show how we can use the unsaturated zone above the water table to store water and to observe what happens to the water we introduce. To do this, we install an infiltration basin in the unsaturated zone. We use red dye and maintain a constant water level in the basin by continuously adding water. The water seeps into the sand, first saturating the unsaturated zone, then reaching the saturated zone below. The red-dyed water pushes the previously infiltrated brew water downward, which we can track through the rising water levels in the piezometers. This confirms that we've successfully stored water underground. Notice that the infiltrated water does not stay in place. It begins to move in the direction of the natural groundwater flow. While this movement is much slower in real life, it still affects areas farther away and increases the overall saturation of the system, as seen in the piezometer readings. As a result, water appears in the previously dry canal on the right side. First, we see the blue water pushed ahead by the red front. Then, after a short delay, the red-dyed water also reaches the canal, confirming that the infiltrated water has traveled that far. This highlights an important point. If we do not account for this movement, we might unintentionally lose the recharged water carried away by drainage canals. That is something we definitely want to avoid. Finally, when we stop the infiltration, the water in the canal disappears and the piezometers show that the saturated zone returns to its original level. This means that to maintain a higher groundwater level, infiltration must be continuous. All of this demonstrates how crucial it is to manage surface and groundwater together. If we recharge water underground, we must also ensure that it stays there, rather than letting it drain away. This integrated approach is at the heart of an innovative method developed by researchers at ELTE, NaBa-MAR, a landscape-scale, nature-based solution for managed aquifer recharge.